All right. You guys hear me okay? Am I too loud? Good. Thumbs up, thumbs down, head nods. Okay. So sorry about last week. I did not plan on not being here. So I'm all right. I'm doing okay. I might be a little bit more stationary up here. Look at Canvas. You know, I don't expect anything to kind of happen moving forward, but that's kind of where I'll try to get announcements, get information out to you if I'm not able to be in class. That's always a good place to look at the announcements on Canvas for kind of updates in the class. We'll kind of pick up. I'm assuming that you've watched those replacement lectures that I posted on YouTube. So unlike what they usually do, those had me doing a bunch of work on them, so you could actually see the recording of me working on things. One of them I recorded last week while I was at home. Moving forward, the recordings aren't supposed to be a perfect replacement, so I had someone ask me, well, I can't see what you're doing up here. I mentioned that week one, right? You're not supposed to. That's why you come to class, to kind of get everything I'm going to be doing on the dot cam. But the audio recording of what we're doing, kind of what we're looking at on the screen, that's what will be kind of recorded and what I'm posting to YouTube if we actually have class. If we missed class like we did last week, I'll always kind of put a replacement up where you have everything. Okay. So we're moving quick. Module 3, unfortunately, is a pretty important module. So if you didn't watch those videos, you really need to, right? Because we're going to build upon a lot of what we talked about in Module 3 for the remainder of the semester. I'll kind of keep this in mind and kind of probably review things even this week a little bit from that module, as well as when we start to use things from that module moving forward. I wanted to mention a couple things before we jump into material today. So I had an announcement up here from, I guess, almost 2 weeks ago now, but just a kind of reminder. So if you come down here, these extra tutoring sessions, not only do we have kind of the CL sessions, which one of them had to get canceled last night. I got a late email about someone being violently sick. So one of the locations was not available last night. I got that up as soon as I was made aware. But in addition to those CL sessions, Tuesday, Wednesday, and Thursday nights over in Wiley Hall, there's free economic tutoring sessions. I think I might have mentioned these in class, that they're not specific to this section or course. Really, any econ course can go there and ask questions. But I will give you a little bit of a hint. So on Wednesday from 7 to 9, I know one of the students there is one of the CL leaders who has worked for me before and who I find to be pretty good. Very good, I should say, right? So she's always going to be there 7 to 9 for those free economic tutoring sessions. So she will be aware of things specific to this course and to this section, right? So if you're looking for additional kind of help as you're kind of learning this material, those Wednesday night sessions, those free economic tutoring sessions, I know someone is there who's very aware of what's going on in this specific course. The other ones, they're great. They'll be fine too, Tuesday and Thursday. They just might be answering questions about 251, 252, 370, about a bunch of different courses. I know specifically there's someone there who will be very good at answering 251 questions for this course on those Wednesday nights, okay? Other than that, we'll kind of get back into that same routine. So we'll have lecture today, Thursday, after Thursday's class. Module 4 quiz will be posted. There will be no module reading posted because what's next week already? That first midterm, all right? So we cover 4 modules, have a midterm, 4 modules, midterm, 4 modules, final, okay? So I have put up, and I'll get it up here on the home tab. I just didn't want to put it up without mentioning it in class and freak anybody out, but it is under the files tab. I've got that first practice exam up for the upcoming exam. I may get another one posted up with some additional questions later on this week as well. But if you want to start looking at the types of questions you'll be seeing on that midterm, sorry if I said final, on that midterm, this is going to be a really good set of questions to start looking through. And I've got the answer key up there. If it were me, I would probably try to work through the questions without looking at the answers first, see which ones I got wrong, make sure I really understand why I got those wrong. If I don't, those are good questions to ask next Tuesday, because even though our exam's next Tuesday we won't have new material. So I said there's no module reading this week because we won't do new material next week. Next Tuesday, I will literally just be going through practice problems, right? So what's going to be more beneficial for you is if you've looked at these, and like I said, the second set I post here probably sometime tomorrow. If you look at those ahead of time, I will field the class for questions, and that way it's a lot more efficient because I'm answering questions that you actually have. If everybody's shy and quiet, I'm going to pick and choose what I think you might want to see the most, but I don't truly know that, right? Unless you ask me, okay? So next Tuesday's class should be very kind of, what's the word? Like, you should be really participating a lot, asking me questions, because it's not meant for me. I don't have to be here. I don't care. I could just say, oh, you don't have class next Tuesday, get ready for the exam. I'm coming to class next Tuesday to be able to help you get prepared for the exam. You help me help you, right? Next Tuesday. So we've got that coming up. And I'll mention more about the exam during that Tuesday's class in terms of logistics, but it will be in class. I'll have a bunch of people helping me kind of proctor it, and we'll talk more about the specifics, probably even next class, and then next Tuesday for sure we'll go over some real fine details about it. Okay. Any questions for me before we kind of jump into material here? Okay. I will, you might also have noticed, I went in this morning actually, there was a question, and we'll cover it today, on Module 4's reading, where I ended up just giving everybody credit for it. So you might have seen your module reading score. I think it was question 3. I'll talk about it specifically once we cover it here today, but you might have seen that update, and by the end of class today, you'll know why, okay? So let's go here. So Module 3 was all about supply, demand. We can see shifts in supply and demand. We can think about where the equilibrium is. We're going to focus a little bit more specifically today on just demand, okay? So there's a trait or a quality about a demand curve called the elasticity of demand, okay? So, and specifically, we're going to be talking about the price elasticity of demand. So we said the demand curve is a bunch of combinations of the different prices that we're charging for a good and the corresponding quantity demand. If a company is charging a higher price, in general, are people going to want more or less? Less, right? There was this inverse relationship. So we had this downward sloping demand curve. As the price went down, people wanted to buy, or the quantity demanded went up, right? So how much higher it went up or how much more it decreased, that's what we're going to call kind of that elasticity, or how elastic was demand, how responsive was demand to these price changes. So this word of elasticity, if it helps, it's just synonymous with the word of how responsive. So the price elasticity of demand is how responsive is demand. So the elasticity of demand, how responsive is demand to what? Whatever that first word is, that's the thing that's changing. How responsive is it to price changes? Okay. So we'll go through some different types of elasticities. Maybe not so much today, but for sure on Thursday. So just in general, you guys can't see this. Why? Did someone unhook this? Oh, this is going to be fun. For the laptop. There we go. Okay, don't breathe too heavy. So today what we're primarily going to focus on is the price. That's our X, the thing that we can kind of put different words in here through, we'll see by the end of today or Thursday's class. And then the elasticity of what? Demand, right? So the way that I would maybe think about this, the price elasticity of demand, is how responsive is whatever's in the kind of second place, whatever kind of comes at the end of this phrase. So how responsive is demand to changes in whatever word we have first. So for our examples that we're studying out today, price. So the price elasticity of demand, how responsive is demand to changes in price? And then we'll have different things like price elasticity of supply. We might have income elasticity of demand, how responsive is demand to income changes. But this is maybe a way to kind of think about it, okay? So when we see the price go down, how much more are people going to want to buy? That's essentially what we're trying to get at, right? So let's think about going back here. So the way that we're going to measure this is in percentages, right? So you might think if I increase the price from $1 to $2, that's, I mean, let's say, oh, I can think about if I go to like the gas station and all of a sudden the price of gas goes from $3 to $4. Well, that's a sizable percentage change, right? That's a pretty large, even though it's only $1, it's quite a bit for going from 3 to 4. Now, if I have, I don't know, the new iPhone and it's like $1,000, and instead they're like, you know what, let's go 1,001. Is that really going to change many people's decisions about whether or not they want to buy the new iPhone? Probably not, but it's still a dollar change, but it's a much smaller percentage. So we don't necessarily care about the absolute change in price. What we really care about as consumers usually is the percentage change in price. So we're going to measure this, what we call elasticity, this price elasticity of demand. Not just how many more units do we want to buy when the price goes up or down by $1, but what's the percentage change in how many units we want to buy from a specific percentage change in price. So it looks like it's going to be kind of a little counterintuitive, because when we're thinking about things like slope, when I was drawing out demand, what did that look like? So we said when we have demand, we're thinking about the quantity demanded and the price. There's this inverse relationship. And if I wanted to find the slope here, how would I calculate slope? It's the change in my Y, so it would be change in price over the change in quantity demanded. Our elasticity measure, it seems counterintuitive, but it's not the same as slope, right? So when it comes to calculating this elasticity of demand, we're actually looking at what's the percentage change in the quantity demanded. That's the thing that we are interested in. How responsive is it, right? How responsive is demand? So it's the change in the percentage change in the quantity demanded, or a non-technical way of remembering this, when we're looking at elasticities, whatever word comes second, whatever we're looking at the elasticity of, that's what's in our numerator. And then whatever it's responding to, so the initial change was not in the quantity demanded, that's what was responding. The initial change was in the price of the good. So whatever the initial change is in, or in our case, the price, that's what goes in our denominator. So once again, not a technical way of remembering this, but the first word is in our denominator, and that last word is what's going to be in our numerator, okay? So how do we find these? Well, before we talk about calculating these percentage changes, let's just think about some of these traits of the elasticity of demand first, okay? So one nice thing about taking percentage changes is I can start to compare across goods. Like maybe the responsiveness of changes in price to gasoline, right? I have to have it to get wherever I go. So if people have to have something, what do you think as a company I could get away with? Changing the price by quite a bit, and they'll keep buying the same amount. There's going to be some goods that if people need them, they can't be very responsive to price changes. Now, there's going to be other things that are kind of frivolous, or like they're not necessities, right? So maybe if you think about, like, I don't know, for some people this might not be true, but like a Starbucks coffee drink, right? Well, I can make coffee at home. Why am I going to go spend $5 or $6 at Starbucks? So if they change the price, maybe I go from buying something from them to buying nothing. That's a huge percentage change, right? So different goods will have different price elasticities of demand, and we want to be able to compare those. Well, when they're in different units, I can't compare cups of coffee to gallons of gasoline, right? So I need a unitless measure. Percentages are unitless measures. So once we have these price elasticities of demand, I can say that coffee is more elastic to price changes than gasoline or textbooks or whatever the good is, right? So that's one nice thing. So there's this kind of, just to make us put some numbers to this, make it real easy. Let's say we have this example where Netflix all of a sudden increases their prices, right? And they, have increased their price by 50% here. Well, what's always going to be true about our price elasticity of demand? If Netflix increases their prices, holding everything else constant, what should happen to the quantity demanded? Should go down. So what's going to be true about my price elasticity of demand? It will always be negative, just like the slope of our demand curve. Now, when we talk about the price elasticity of demand, let me see, there we go. I'll come back to that slide here in a second. What we always do is kind of throw in one more thing. I take the absolute value, all right? Because we know that every good is going to have a negative price elasticity of demand. It gets kind of weird talking about larger negative values actually signal it's more elastic. And so to make it easier, we're just concerned about the magnitude, right? So we look at the absolute value or essentially drop the negative sign. So the one question I ended up giving everybody credit for, they asked you to calculate the price elasticity of demand. A lot of you put a negative sign, it counted as wrong. And that's because truly it was wrong, because the price elasticity of demand, the last step is that you always just want the absolute value. Now, we hadn't talked about it yet. To be fair, it might not be quite clear in the reading, and that's why I gave everybody credit for it. Moving forward, I'm not going to try to trick you. That price elasticity of demand should always be a positive value. We just care about the magnitude, okay? So if I were to go back here, we already talked about why it's negative, but once I've got those percentage changes, it's really easy to just plug these in and figure out what the price elasticity of demand is. Okay. Now we're going to have different ranges. So once we take the absolute value, right? In this example, it was what, negative 0.5. So I take the absolute, just 0.5, right? What's going to be true? And I'm going to jump the gun a little bit here, but I think it makes sense at this point. So let's say I have an elasticity of demand and it's greater than 1. What is that telling me? Well, how did we calculate the elasticity of demand? It was the absolute value of the percentage change in the quantity demanded to the percentage change in price. Well, if I take the absolute value, I can kind of ignore that. All right, if I had the absolute value of both sides. So what is this really saying? Well, if I multiply both sides by the percentage change in price, what am I left with? That anytime the elasticity of demand is greater than 1, the percentage change in the quantity demanded must be greater than, anything times 1 is itself, the percentage change in price. So when I have an elasticity greater than 1, what that's saying is anytime there's a percentage change in the price and it's less than the corresponding percentage change in the quantity demanded, that's telling me that, yeah, the price is only going up here by 25%. And as a result, people are buying 50% less. They're responding in terms of percentages by an even larger amount than the initial price change. Okay. Now, what would be true if I had an elasticity of demand less than 1? Well, once again, you could write this out and think about, okay, I've got my percentage change in the quantity demanded over my percentage change in price. What's the only way this fraction is less than 1? Maybe this is a different way of thinking about it instead of like cross multiplying everything. What would have to be true for this fraction to be less than 1? The percentage change in my quantity demanded would have to be what relative to the percentage change in price? Yeah, that numerator would have to be smaller for me to have a fraction less than 1 here. So anytime people are changing the amount they buy by a smaller percent than whatever that initial price change was, they're not being as responsive in terms of how much they buy relative to whatever that change in the price was. So here, anytime we have an elasticity less than 1, we're going to call demand inelastic. So remember, elasticity you can think of as responsive. Inelastic would mean like unresponsive, right? Not irresponsive, unresponsive, right? Anytime we have an elasticity greater than 1, people are responding by an amount larger than the initial change in the price. So there we would say they're being very elastic, right? They're being very responsive. Okay. Any questions on this? Okay. So I left out one. What's like another possible scenario here? Yeah, if it's equal to 1, what would that have to be? Unit elastic, or we can think about if my elasticity is equal to 1, what would have to be true? Well, if I've got my elasticity as the percentage change in quantity demanded over the percentage change in price, what's the only way that this fraction is 1? My numerator would have to be what? The exact same thing as my denominator, right? So unit elastic is in a way you can think about it like people are perfectly responding to that price change. And it's not really perfectly, but like the percent change in their quantity demanded is the exact same as that initial percentage change in price, okay? we don't see this happen in practice very often, right? To be exactly equal to 1. Usually you're going to end up in one of these ranges, okay? Any questions there before I go back to the slides? You good with that? All right, it's not too bad. All right, so we've got our price elasticity of demand we already talked about. We take the absolute value, so we're always going to be able to kind of compare across goods, okay? Before we get too lost into the weeds of the midpoint method, like I said, I'm jumping ahead here. Maybe I'll rearrange my slides for the future. Let's say I had a good, and I don't know, we'll say it's the elasticity of demand for gas. And what was the other one? I was saying the elasticity of demand for, I don't know, Starbucks, right? Let's say this was, I don't know, 0.3, and this was 0.5, okay? What are both of these goods? We would consider both of them what? If it's less than 1, inelastic. But which of these would I say is more inelastic? Yeah, gas. Why? Because it's closer to 0, right? In fact, if I had an elasticity of demand for a product and it was equal to 0, what would that mean? Well, remember, maybe if it's hard to think about this, write out what the price elasticity of demand is. It's the percentage change in quantity demanded over the percentage change in price. If this was equal to 0, what has to be 0 in this equation? My numerator. So what would that mean? The percent, anytime that the company changes their price, they increase the price, are people buying more or less? No, right? They're being completely unresponsive, right? So if I ever have an elasticity of demand equal to 0, just to kind of combine this, what would my demand curve actually look like? So the price is changing, but the amount people buy isn't changing. So that means I would have a demand curve that's actually completely vertical. Very weird. Like, this is the extreme scenario. There's nothing that's well, actually, I can tell you something that's probably perfectly inelastic, or at least very close to it. If I need cancer treatments because I have cancer, do you think I care about the price? No. There's stories of people robbing to get the money to do it. There's people, if you need something to stay alive, what is your demand for that product? Completely inelastic. You don't care what the price is. You need whatever it is to stay alive, right? You could come up with goofy examples like, I don't know, watch Walking Dead and, they need something to stay alive and they'll kill the person that's part of their group just to get it, right? They don't care, right? They're completely unresponsive. They need a certain quantity. Now, do we ever see something perfectly inelastic? Probably not. But this might help you remember, oh yeah, as I get closer to 0, that's more and more inelastic, right? That's more and more unresponsive. I'm being less responsive to changes in price there, okay? On the flip side, let's say I had an example where I had the elasticity, and let's say, I don't know, say for houses, let's say it's I don't know, 2.5. And I've got my elasticity of demand for, I don't know, I saw one of these the other day, so it's in my head. G-Wagons, right? Right? Both of them, I don't need them. They're kind of luxury goods. Here, because both of them have an elasticity greater than 1, I'd say both those products are elastic. Which one is more elastic? Whichever has the higher value, right? In fact, what would the highest elasticity of demand be? Yeah, infinite, which is kind of weird, right? So once again, if I think about what that would mean, if I have the elasticity of demand, it's infinite, what's that going to look like? Well, that means that how would this be infinite? If the denominator, it's kind of a weird math question. What would the denominator have to be for this truly to be infinite? Really small, theoretically, it would have to be 0, which would actually mean that people would change. Like, there's going to be they want to buy more, even if the price change is 0. They're responding even when there is no change in price. We would say they're being perfectly elastic. They're responding to your point, in practice, probably not a zero change, but an infinitesimally small percentage change, a 0.00001 percentage change in the price. What's something that we can see people be pretty close to perfectly elastic for? This is probably not the real bet. People will not buy a home over, like, you go out in Zillow, people like drop the price of a home by like $1,000 and all of a sudden someone decides to buy. It's like, it's already $500 and some thousand dollars and all of a sudden they like just get it below a threshold, they get it, oh, it's $499. Well, now all of a sudden people decide it's a good deal, So if we had truly perfectly elastic demand, that means that even if the price stays the same, what's happening to the percent that people want to buy? It can be changing. So perfectly elastic demand would actually be a horizontal demand curve, okay? So this is where, and we'll probably touch on it here a little bit, slope and elasticity are not one-to-one. But as the slope gets steeper here, what do we know the elasticity is getting closer to? Well, if it's getting steeper, it's getting closer to being completely vertical, and we know that it would be perfectly inelastic, right? So even though it's not one-to-one, when we're looking at demand, as it becomes steeper, we're looking at more inelastic goods. As it's becoming flatter, it's getting closer to being perfectly elastic, very responsive to price changes. So there we would say, as my slope is getting flatter, we're actually seeing this product get more and more elastic, okay? So there is, this kind of relationship between slope and elasticity. It's just not this one-to-one. You can't tell me that if the slope goes up by 2.5, how much would the elasticity change by? We can't do that. But we can say that as it gets steeper, it's more inelastic. As it gets flatter, it's becoming more elastic, okay? Any questions on anything there? Like I said, I'm jumping the gun a little bit. We'll look at the calculation. I'm not as concerned with this because, this just becomes mathematics, right? So let's say I had this example in what? I had the price going from 100 to 80, right? Well, if I go from $100 to $80, that's a 20% reduction in price, right? Going down by $20 when I start at 100, that's a 20% decrease. The problem is, if I go from 80 to 100, so let's say instead of the price falling from 100 to 80, it went up from 80 to 100. Movement between the same 2 points on the demand curve. Remember, we're looking at the price elasticity of demand. So ultimately what we're doing is we're calculating the elasticity at some point on the demand curve. Well, we're at the same point. We're moving between the same two prices and would be the same two corresponding quantity demanded. But notice if I go from 80 to 100, what percent increase is that? Well, now if I go up by 20 and I start at 80, that's actually a 25% increase. So movements between the same 2 points, but in different directions, I get different percentage changes. So what we're going to use for this class, and outside of this class, we'd be dealing with like non-linear demand curves. Elasticities get a little bit more tricky to calculate, but it's the same general idea. We're going to use what we call the midpoint method. We know that depending on if we started at 80 or 100, even moving between these same two prices, same 2 points, we would get different percentages. Well, we're going to take the average of those two, right? So what you could do is if you wanted, calculate this percentage, then take the average here. So here, the percentage change in price between 80 and 100, we would say is what? 22.5%, right? Or, well, I've got it up here, but we'll focus just on this first equation, that denominator. Or I could take what is the change in that price and then divide it by the average of that price, right? So if I go back to my example here, I could say, okay, if I'm between these 2 points, what would the change in the price be? 20, right? If I don't care about the direction, I just care about what's the change between these two, in absolute terms, 20, divided by what's the average price here. So what's the average of 180? Add them up, divide by 2, I would have 90, right? Take 20 divided by 90. That would kind of give me my percentage change in the price, okay? So that's what we have in that denominator. So, instead of having to calculate the percentage change moving in different directions, all we have to do is look at what the change in the price is, what two prices are we moving between, and then what is the average of those two prices. That would ultimately give us our percentage change in the price between those 2 points, no matter if we're going up or down, right? Now, if you actually calculate this, like if I took in that previous example 20 over 90, what's that actually going to be? That's going to be a fraction. So in this equation, it'll have like your percentage change. It's just going to be in decimal form, right? We'll do the same thing for the quantity, right? Once we know that we're moving from 80 to 100, we want to see, okay, what was the change in the corresponding quantity demanded? We'll use the midpoint method there, find the change in the quantity, divide it by the average. If I want to write this out just to be like a little bit more specific in what I'm doing, how do I find the change in two values? I subtract one from the other. That shouldn't be a revelation to you guys. How do I find the average of two numbers? I add them up, divide by 2. So if it helps, don't try to enter this into your calculator all at once. Like maybe try to find this value, try to find this value, plug it in, then get the numerator. Like kind of break it up into parts. And I'll show you with some actual numbers maybe what that would look like. I've got them kind of color-coded here. Just kind of think about like, oh yeah, that's how I calculate a change. That's how I calculate an average of two numbers. Once again, I don't think either of those two things should be too crazy, right? And then we always have to remember, we want to be able to compare across goods. We always know the price elasticity of demand is going to be negative, so we just look at the absolute value. So let's work through an example. So let's say I've got what, a price of 6. At that price, people want to buy 15. They lower the price to 4. The new corresponding quantity that people want to buy is 25. Okay? So if I was working through this, here's maybe how I would do it. The slides might have it broken down a little bit differently if you're more mathematically minded. So we think about, okay, if I have this price elasticity of demand, I know I'm always looking at the absolute. Oh, sorry. We'll start over. Price elasticity of demand, it's going to be the absolute value of the percentage change in the quantity demanded over my percentage change in price. Okay. Anytime we want to calculate a percentage change in this class for elasticities, we're going to use this midpoint method. So it doesn't matter. We'll talk about other elasticities later on. Any percent change we want, we're going to be looking at, well, what is the percentage change in the quantity demanded? That is the change in the quantity demanded divided by the average quantity demanded. Okay? And then what is the percentage change in price? That's the change in price divided by the average price. Now, we could use the other form where we write out, okay, how do I find a change? How do I find an average? I think you guys probably know how to do that if we're just looking between two numbers. So in our example, I think we had what? Price was 6, quantity was 15, moving to a price of 4, quantity of 25. So here's where I would do it this way. What's the change in the quantity demanded here? I mean, if we can't do this, we got a problem. What's the change in the quantity demanded? 10, right? This shouldn't be, so okay, so I found the change in the quantity demanded. What's the average? Well, even if this was, I don't know, two trickier numbers, how do you find the average of two numbers? Not breaking news here, right? So if I add these up, I get what, 40 divided by 2, my average is 20. So instead of like plugging all this in at once, I would do something like this. Okay, I just found the numerator. It's going to be what? 10 over 20 or 0.5. Okay. I then might say, okay, what's the change in the price? 2. What's the average price? Add these up, divide by 2. 10 over 2 is 5. Maybe I need help with my calculator. I enter this in my calculator. I find this is what? 0.4. Now, I could do this all at once, right? Or I could find these values and just make it easier on myself when I go to finally enter into my calculator, okay? Now, looking at this, I don't even necessarily care what the value is. Oh, sorry. If I didn't necessarily care what the value is, if I just asked you at this point, and say you didn't have a calculator and these numbers were harder, why could you tell me is demand elastic or inelastic here? Elastic, why? If the numerator is greater than the denominator, what do you know the elasticity is going to be greater than? So you know it's elastic. Now, if you want the actual value, you might have to plug this into a calculator. I get what? 1.25 if I'm doing math in my head correct here. Okay. So, break this down as much as you need to make it easier for yourself. If you got a calculator and you can throw in all the parentheses and make sure you're doing your order of operations, by all means, go ahead and do that. I just always think it's a little bit easier to kind of make sure I'm not making a mistake if I try to break this down into steps. But it's individual specific, right? So here, right, once again, I could plug all the numbers in at once. Just have to make sure I'm doing parentheses correctly in my calculator, right? Either way, doesn't matter how, whatever I do, I should end up with 1.25. Now, technically, if I was doing this correct, I would have come up with, notice I have a negative sign here because our price was actually going down. So I was being a little bit lazy with what I was writing. I should have wrote -2 was the change. But ultimately, we can kind of ignore the negative sign because we know we're going to ignore it at the end. When we look at the price elasticity of demand, we just care about the absolute value. Okay? Any questions on this before we keep moving? Okay? All right. So I've jumped the gun here. We already talked about this, but this is kind of a summary of what I was writing out for you earlier. So, and it really comes down to it's all about that relationship of my numerator to my denominator tells me whether or not this fraction is greater than or less than 1. Well, if it's less than 1, that's telling me the numerator is smaller, which means that the change in price is greater than the corresponding change in how much people are buying. So we would say they're not being very elastic or they're being inelastic. If it's greater than 1, that tells me the numerator is larger. That means that they're responding by a larger percentage than whatever the initial change in the price was. That's why we would say that demand, there is being elastic. And then the one in the middle, we just don't see it often in practice, but it can happen, is that we have unit elastic, which is that the numerator is the exact same as the denominator, or that percentage change in price is the exact same as the percentage change in quantity demanded. Okay? Any questions on that? Like I said, I know we covered that earlier. Okay. We already kind of talked about this as well. I kind of gave you the general rule of thumb that if I'm looking at demand curves, if I wanted to compare across different goods, generally products that have steeper demand curves, we said if it's steeper, that's getting closer to what? So this is the way I always think about it. If I have a really steep, I would draw it out. So people sometimes will ask me questions as we get further into the semester, how do you visualize? There's probably a drawing you can have for every problem that you're looking at. And I always think about the extreme. The steepest demand curve you could get is vertical, right? So what does that mean? If I have a vertical demand curve, what's happening to the quantity demanded? It's not changing at all. So if I have no change, my percentage change in that quantity demanded is equal to 0, then when I'm thinking about my elasticity, it doesn't matter what the percentage change in price is. If this is 0, what will my elasticity always be? 0, right? And as I'm getting steeper and steeper, this is where it's kind of counterintuitive. Because as I'm getting steeper and steeper, I'm getting closer to an elasticity of 0. But what's happening to my slope here? As I get steeper and steeper, my slope is actually getting, so if I have a really steep line, the slope is going to be really large, right? Because how do you calculate slope? We said earlier, it's the change in y over the change in x. Notice it's the inverse of how we calculate elasticities. So the general rule of thumb is, if I have a steeper curve, and that's where maybe you don't want to get tripped up by the actual numbers, but if I tell you that the slope is larger, a larger negative value, it's actually steeper. But as I'm getting steeper, I know the elasticity is getting closer to 0. And then you could do the same thing if it's getting flatter. You know that the slope is actually getting closer to what? Completely horizontal curve, the slope would be a horizontal curve has a slope of 0. You guys are scaring me. All right. We should know that coming into freshman year of college, right? A slope of a horizontal curve is 0. But what would the elasticity of a completely horizontal demand curve be? Well, if it's completely horizontal, what is not changing? Price. So when I'm thinking about my elasticity, if the price is not changing, the percentage change is zero. Anything over zero is infinity, or I'm looking at very elastic products. Okay, so this is why slope and elasticity are related, but they kind of are inversely related, right? They kind of go in opposite directions. So it can be a little confusing. I completely understand that, right? But I think sometimes drawing it out and kind of thinking about what that equation is for the price elasticity of demand can help you sort that out a little bit better. Okay. So we've got really 5 different classifications we could look at. I've already kind of alluded to some of these. We said if I had a completely vertical demand curve, when the price changes, what's going to happen to the corresponding percentage change in quantity demanded? It will be zero, nothing. So 0 over anything. I chose 10 here, but the percentage change in price could be 100, could be 200%. If it's perfectly inelastic, people don't respond at all, that price elasticity of demand will always be 0. And then we said the slope, it's kind of tricky because here, if it's completely vertical, the slope is actually going to be not 1. If it's a completely vertical, infinite, right? And so if I'm a company, do you think I like this? I mean, if it's completely inelastic, that means I could increase the price, and what are people going to do? Buy the same amount. If I'm selling the same amount, but at a higher price, what have I done? Increase my revenues. And we'll talk more about that Thursday, but just kind of sprinkling these ideas in today. If instead of perfectly inelastic demand, we just had something where the corresponding percentage change in the quantity demand, it was just something less than that percentage change in price. So I'm using 10% here to kind of keep using that same value. Let's say that, okay, they didn't change the amount they were buying by nothing, right? But maybe they bought a little bit less when the price went up, but not 10% less, something less than that. So their response to the price change, they responded by less than what that price change was. So we said those consumers are going to be pretty inelastic, right? Not perfectly inelastic, but somewhat inelastic. And that's kind of our next range. And then we had the next one. Well, here I've got a meme. I must have liked this at some point. Do you guys know who this is? What's his name? Martin Scarelli or something. Go look it up. Martin Scarelli. No, am I getting that mixed up with the kid from Recess? That old, whatever his name is. He bought the rights to HIV drugs and then jacked the prices up and became a villain, and I don't know. He's not a great guy. But this is the idea we already talked about. If I'm a company, if I buy the rights to HIV medication, what do you think is probably true about the elasticity for HIV medication? Do you think it's pretty inelastic or elastic? I need it to not die from, to develop AIDS. So it's probably pretty inelastic. So as a company, what can I do? Well, I know people need to keep buying the same amount. Then I'll jack the prices up. Right? I know they're going to be pretty inelastic. Okay. The other category we talked about, which is pretty easy, the other extreme, I shouldn't say easy, but perfectly elastic. We're completely responsive. Even if the price doesn't change, people all of a sudden change how much they're buying. Well, any number over 0 we said is going to be what? Infinity. So we've got completely perfectly elastic demand. If when there's no price change, people change how much they're buying by anything. Even if it was 0.1%. 0.1% over 0 is infinity, right? Now, the slope, it's kind of the inverse of that. We said it's a completely horizontal demand curve if it's perfectly elastic. That means we'll have a slope of 0. Okay? Do you think companies like this? Well, if I don't change the price and all of a sudden people just decide they're going to buy less, is that a good or a bad thing? It's not. I mean, it's pretty unpredictable. And in fact, this would suggest if I deviate the price, it's kind of weird. I haven't been drawing this out for us. But with perfectly elastic demand, if I deviate the price at all from this point, so if I keep the price here, well, maybe they'll buy this amount, but maybe they'll buy even more. But if I change the price by even a little bit, what does demand go to? 0. So technically, there is this horizontal demand curve, But as soon as I raise the price a little bit above that, demand goes to 0. So do companies like that? No. That means if I change the, by 1 cent, no matter what the price is, it would go to 0. Now, is there any good that's like truly perfectly elastic? Probably not. But there's good that get close to it, right? And then we have kind of the only other another category we can think about is it's not perfectly elastic, but it's just elastic, right? So we've got some percentage change in the price, and the corresponding change in how much people are buying is something larger than that. They're being even more responsive in how much they buy relative to whatever the initial change in the price was. There we said we'd have an elasticity greater than 1. And then I think we've got unit elastic. This is the one that I think is relatively easy. It's when that percentage change in price is the exact same value as the percentage change in the quantity demanded. We would say we have unit elastic demand, okay? So once again, I kind of went through some of this already. That's why I went through a little bit quicker here. But I kind of have a nice summary on the slides, kind of back to back. Any questions on this before we keep moving? I got one more thing I want to kind of look at here. So before we go through these, I think I'm going to do this in a slightly different order today. Because sometimes I can tell you things I already know, right? So it's better if I kind of lead, as they say, lead a horse to water, right? Not that I'm comparing you guys to horses, but that's the age-old saying, right? So we'll try to see if we can piece together, instead of me just telling you, kind of piece together what the answer to the question would be based off what we've already talked about. So let's see, we've got, it's 10:20. Let's go. We'll spend a little bit of time on this. I'll leave it open a little bit longer. Make sure I've got the date right. Okay. So we'll spend about 10 minutes on this quiz. Excuse me. So it should now be up. I'm just going to double check. Should be up under that module 4 in class quiz 4.1. So I'm going to pull it up here. We'll talk through it together. Going to build. Should have a preview button somewhere. There we go. And we'll kind of talk through these, right? Now, I'll probably go kind of quickly through some of these. I could rely on you guys to answer them on your own. But I don't know. I'm feeling nice today. We missed class last week, so we'll kind of talk through them together. So this first one, if I've got the change in the price of textbooks being 24%, and as a result, so first of all, I told you there was a change in the price, just to kind of get these concepts down. I told you as a result, people decreased how much they bought by 15%. Okay. So if people are buying less, what must have been true? That change in the price must have been a what? So if people are buying less, the price must have went. So it wasn't just a change in the price here. You could actually tell me that the price increased by 24%. If I had added like another part of this question, that said, what must, the percentage change in the price must have been increase or decrease, could have been the options. That could have been like a second part of this question, okay? Because I just told you there was a change. But knowing that people bought less, remember this price elasticity of demand, I'm drawing, showing you the extremes and other things, I'm drawing out demand curves. We know the demand curve is always downward sloping. So just kind of pointing that out. Now, I didn't ask you to calculate the specific value here, right? I could have. I gave you the percentage changes in the quantity demanded and the price. What would you do to calculate the elasticity of demand? What goes in the numerator? So remember, we said if it's the price elasticity of demand, whatever word comes last, that's what we're looking for the responsiveness of. That goes in our numerator. So for us, the price elasticity of demand, the percentage change in quantity demand would be in our numerator. So 15, right? What's in our denominator? Well, what was the initial thing that was changing? What was it responding to? A change in price. So that 24 would go in our denominator. 15 over 24, I might not be able to do that in my head, but what do I know it's definitely less than? 1. So I know that this product, I would say demand is inelastic, right? And that's all I need for this problem, right? Now, if I wanted the specific value, I probably need a calculator, 15 over 24, whatever that ends up being. It's close to 0.6, right? It's going to be slightly over 0.6 if I'm doing math in my head, thinking about this correctly. Okay. Any questions on that idea? Okay, so that should be hopefully not too bad. Now here I've got one where we actually want to try to use the midpoint method. Okay, so I've got two prices and I've got the corresponding quantity demanded. So I'm going from a price, I think I did gym memberships, $20 to $30, right? And then as a result, they sell 120. They go from selling 120 to selling 100, right? What is the elasticity of demand here? Now I should have been a little bit more specific in my language. All we've talked about today is the price elasticity of demand, so that's probably why I wasn't. But to be technical, what is the price elasticity of demand, right? So the initial change in the price, I went from 20 to 30. So this is where I'm going to have to use my midpoint method, right? So if I've got my percentage change in the quantity demanded over my percentage change in price, we said anytime we want to find a percentage change, so if I just focus on the numerator, we're going to take the change in that thing and divide it by what? Do you remember? The average, right? So in my example, I think we had what? We had 120 gym memberships, and then we sold 100. So what was the change in my quantity demanded? Once again, I'm not giving you crazy numbers here. What's the change? Technically, it went down by 20, right? What's the average? Well, how would I find the average of two numbers? I would add them up, divide by 2. So what? 220 divided by 2 is 110, right? If somebody wants to help me out, this is what? 1 over 5.5. So whatever that works out to be in decimal form. Here, I've got Excel pulled open here so I can cheat. What? 0.1818 repeated. Okay. Now, so I now have my numerator. How do I find my denominator? Well, that's the percentage change in price. That's going to be my change in price over the average price. I think the price in this example started at 20. It went to 30. So what's my change in price? It went up by 10. What's the average? Add these two numbers up, divide by 2. So 30 plus 20 is 50. Divided by 2 is 25. This one should be a little bit easier for me to do in my head, 0.4. Now, it's just a matter of 0.1818 over 0.4, whatever that works out to be. So what, 0.5? So if I took I take the absolute value here, because which one of these should have been negative? I was getting lazy. This one, right? Right? So I should have what? 0.4545 repeated. So if I'm rounding this, about 0.45. Okay. So any questions on this one? Okay. Now, when I'm using this midpoint method, something to kind of point out here is when I'm using these decimal values, right? Oh, sorry. There we go. All right. So I get 0.45. Remember, the elasticity itself isn't in terms of percentages, right? And when I'm doing this midpoint method, if I do break it down into steps, I won't actually have the percentages. So here, notice I've got decimal values. Really, what would these represent? I could have also plugged in what? 18.18% and then 40%. I could just convert those into percentages. And either way, I would end up with 0.4545, right? So like in the first problem, we had the actual percentages. So I could just go ahead and plug those in. If I have to use the midpoint method, I'm still calculating percentages. But if I do the intermediate calculations, they won't look like percentages. They're going to be percentages in decimal form, okay? But it doesn't really matter. We don't have to do any converting or anything. We just plug them in, and we ultimately end up with the price elasticity of demand we wanted, okay? Any questions on that one before we keep moving? Okay. So just to, well, we'll finish this out now. Well, I'll ask it here. So what's going to happen? Let's say I had that same change in the price, 20 to 30. But instead, the gym went from selling 120, instead of going to 100, they only sold 60. What should be true about my elasticity? I can say that it's greater than or less than a specific value. So if we just calculated this, we had percentage change going from $20 to $30, and the corresponding percentage change in the quantity, it went from 120 to 100. If instead it goes from 120 to 60, what percent change is going to be larger? So what did that 120 represent? That was a quantity. So if instead of going from 120 to 100, I went from 120 to 60, the percentage change is going to be larger. So what's going to be larger in my elasticity calculation? My numerator or my denominator? So if the numerator is larger, the denominator stayed the same, my new price elasticity of demand will be larger. And that makes sense. It's measuring how responsive they were. It's the same percent change in price, but now people are, or this company is selling even fewer gym memberships than before. People are even more responsive than they were before, so we should have a price elasticity of demand that was greater than it was before. Okay? Any questions on that one before we keep moving? Okay. We've already talked about this one. So which of the following would be true if we had perfectly elastic demand? So we said if consumers are perfectly elastic, we could have no change in the price, and they're going to change how much they buy. So if there's no change in the price, would this be a vertical or a horizontal demand curve? Horizontal. So we already know this one doesn't make sense. Right? If it's perfectly elastic, remember this word of elasticity, we can synonymous with responsive. So would we say that if it's perfectly elastic, are consumers being responsive or unresponsive? Responsive. So to say that they're not very responsive doesn't make any sense. So we're just kind of process of elimination here. The price elasticity of demand has a slope of 0. Well, we said if it's perfectly elastic, you told me it was a horizontal demand curve, which would have a slope of 0. So that one should be true. So hopefully this one's not. The price elasticity of demand is 0. If we had a horizontal demand curve, what percentage change in our elasticity equation would be 0? So if it's horizontal, that means the y value is not changing, right? What was on our y-axis when we graphed demand? So if we have a 0% change in price in our elasticity equation, where was price? In our, so if 0 is in the denominator, that would make our elasticity of demand, anything divided by 0 would be infinite. So it wouldn't be 0, it would actually be infinite. So we can do process of elimination. We ruled these 3 out. We also said why this is going to be the one that ends up being true. Okay? Any questions there before we keep moving? And we got a minute or two. I had it set. So which of the following is going to make demand more elastic? Okay? So I'll tell you right now so we can get it submitted. Let me look through these. So fewer substitutes, no. Relatively low price, no. So this is the one that should be the answer, and we'll kind of talk through why. But I just want everyone to get this submitted. I think I had it set to be due at 10:35. So what, minute or two. So make sure you're kind of getting these answers kind of selected, and then submit this in the next minute. Okay? Any questions on this before we keep going here? So I'll talk through this one still. So what's going to make the price elasticity of demand more or less elastic? So one of these things we didn't quite get to today, so I'm going to kind of maybe set us up a little bit for some of the discussion we'll have next class. So let's just think about each one of these options. So if I have less time to make a decision, right? I'll set this up. Actually, we'll do a different one first. Let's start with the second. So if I have fewer substitutes for a product, okay? So let's say, you know, I go, I don't know, what's it called now? It's not oh, it was Deer Creek, and then it was White River. I don't remember the concert place. It's an outdoor concert venue in Indianapolis. Ruoff, okay. It changes all the time. So let's say you go there and you want to get something to drink, and they've got like, I don't know, 2 different beers to choose from. Not that any of you are buying beer yet, but let's say they had 2 different beers you could buy, right? Well, if all of a sudden they increase the price of one up, right? Let's say they had 2. One of them is now all of a sudden more expensive. What are you more likely to do? Buy the other one, right? If the other one doesn't have a change in its price, you're going to be pretty responsive to that. Like, I've got 2 options. If they're both just cheap beers and you increase the price of one, I'm just going to go buy the other. I'm going to be very responsive to that price change. Well, what happens if they take away and there's only one available beer? Well, now if they change the price, I don't have any available substitutes. That's the only thing I can get while I'm at that venue. So if I want beer, what am I going to have to do? Pay the higher price. I can't be responsive to that price change. So if you take away substitutes from me, what am I becoming? I'm becoming more inelastic, right? Now, if you give me all kinds of options, that's why I like automobiles. Like, people are so sensitive. I mean, we're talking about spending $40,000, $50,000, and people will want to haggle with these car salesmen over 500, like a very small percentage change in the price. And they might go from buying it to not. A huge change in the percent change in the quantity demanded. Why? Because they have so many other available substitutes. There's so many other types of cars that might have similar attributes or things that they want. And there's so many substitutes, they're going to be very sensitive to price changes. So the more substitutes you have, the more sensitive you are to those price changes. If you look at, I don't know, you could probably look at small town diners versus like a diner in Bloomington. If I'm a small town diner, I'm like the only place in town to get something to eat, I can get away with charging a lot higher prices. People can't be as responsive to my price changes because there aren't substitutes. In Bloomington, if I start to charge too much, there's probably hundreds. I don't know what the exact count is, but if you drive around Bloomington, there's tons of places you can get something to eat, right? So the more substitutes we have, the more elastic people will be. So fewer substitutes would actually not make them more elastic. It would actually make them more inelastic. Now, if you think about time, it's kind of tied to the substitute. But if I have less time to make a decision, so let's say I'm trying to get somewhere, right, in Bloomington, and I need to be there in like 5 minutes. Gas, I think, is crazy expensive, but I have to be there. I'm probably just going to pay whatever the price is, right? I don't have enough time to find someone to get a ride with. I can't look up the bus route and I don't have enough time to plan for that. Now, if I had a whole day, I could figure out, okay, I don't want to pay these higher gas prices. I can figure out a friend who's kind of going this way at the same time. I could maybe figure out what bus route's going to go there. But if I don't have a lot of time to make the decision, I'm kind of stuck. I've got to pay whatever the current price is. Or think about it this way. If I have less time, what can I not find more of? Substitutes. So less time actually means that it's less likely I can find substitutes. If there's fewer substitutes, we just said it would make the demand more inelastic. So both of these things, less time and fewer substitutes, would make demand more inelastic. Right? Now, the one that I said is true is if I'm spending money on something and it's a greater proportion of my income. So this one might not quite be clear. I'll use the reverse to make the point. If you go into a gas station and you want a pack of gum, if a pack of gum is $1 or $2 and you just want a pack of gum, how many packs are you probably going to buy if it's $1 when you go in there? I mean, I don't know everyone's spending habits. I'm not stockpiling packs of gum. Like if I just want some gum real quick, I'm just going to pay whatever it is, right? And that's because it's such a small amount of money. It's a small percent of my income, right? So if it's $1 or $2, I'm probably still going to buy a pack. I'm not very responsive to that price change. But what's that percentage change in price from $1 to $2? Pretty large. That's a double. I mean, if we use the midpoint method, right, it's not technically 100%. It'll be what, 66% change, but like a pretty large percentage change in the price. So when something is a really small percent of people's income, they're just not as sensitive to changes in that price, even large percentage change in the price, because a large percentage change is still a very small amount of money, right? Now, if I talk about something that's a large proportion of my income, something like an automobile or a house, people, like I said, people will like haggle in these housing, if they're buying a house over like, closing costs sometimes, it's like a couple grand, and you're talking about like a or $500,000 house, that's such a small percentage difference in the price, and it can go from somebody buying one house to zero, right? It's very responsive. The percentage change in quantity demand is very large, and the reason they'll haggle over these really small percent change in price is because even though it's a small percentage change in price, $2 or $3 grand is still a lot of money. That's a really large percent of or a large proportion of my overall income. So when something is a larger proportion of your income, you're going to spend a lot more time. You're going to want to make sure you're getting a good deal. You're going to be a lot more sensitive to price changes. So when something is a greater proportion of someone's income, we see that they're a lot more elastic. Okay. So that's why that was the one that's true. The one that maybe it's not quite as clear. And once again, this is going to kind of open us up to thinking about next class. And we'll revisit these attributes, like things that make demand more or less elastic. But if I'm thinking about if I have a demand curve, up here, if I was like using the midpoint method and I'm calculating the elasticity of demand up here on the demand curve. So in practice, we'll start talking about next class. We don't just have one price elasticity of demand like for the entire curve. We can actually calculate the price. What are we doing? We were looking at between 2 points. So we can calculate the price elasticity of demand between these 2 points. We can also calculate the price elasticity of demand between, we'll kind of call this 1 and 2, right? We can also calculate it down here. So every point of the demand curve will actually have a different price elasticity of demand measure. Now, inherently, when we're up here on the demand curve, what's going to be true about prices? They're going to be relatively high. So even if I go down by 1, what is that percentage change in price always going to be up here? Relatively small, right? A $1 decrease, well, prices are high here, so a $1 decrease is going to be a pretty small percentage change. But my quantities going up by 1, well, what's true about quantities at this point of the demand curve? They're relatively low. So a change in 1, my percentage change in the quantity demanded is always going to be relatively large. So what's going to be true about my elasticity of demand? Well, remember, it's the percentage change in quantity demanded over the percentage change in price. So if my numerator is large, the denominator is small, my elasticity is going to be pretty large, right? So my elasticity, when I'm looking at kind of these higher prices, will always be higher. Now, on the flip side, when I'm down here, prices are relatively what? Low. So the same $1 decrease is going to be a relatively what percentage change? If I start out with a smaller value, a change of 1 is going to be a larger percentage change. Quantities down here on the demand curve are relatively large. So the same 1 unit change in quantity is now going to be a relatively small percentage change. So what happens to my elasticity of demand down here? Numerator is small, denominator is large. My elasticity is going to be relatively small when I'm looking at these lower prices on the demand curve. So our demand curve will have different price elasticity of demand measures as we kind of look at different points on that demand curve. Initially, it will start out relatively elastic. And then as we see kind of more and more of this good bought, demand starts to become more and more, well, if elasticity is small, it's becoming more and more inelastic. Okay? Another way of thinking about this is if I have more of something, what did we say is happening as I have more of it? The marginal benefit is declining. So if you're changing the price and I don't value the thing as much, am I going to be more or less responsive to that? Well, if I don't care about it and you increase the price, I'm going to buy quite a bit less, right? So that it's kind of going on in the background as well. We'll focus a lot more on this kind of next class. But I wanted to at least kind of, I had the question sitting in the quiz. I wanted to at least kind of touch on it today. So what we'll do next class, I'll kind of revisit these determinants of demand. We'll look at some specific goods. I'll also kind of show you the relationship between elasticity and revenue. I also look at this data. So I want to actually try to like sprinkle in throughout the semester, working with some actual data sets, applying kind of this midpoint method to an actual product, and see if we can come up with what the price elasticity of demand is, and then make some statements about like its revenues if they change prices based off what we talk about next class. So for you guys, right, that Canvas discussion, I'm going to have my GAs help me grade that. So you might start to see grades pop up for that right now. I think it's hidden to you. Am I right on that? Yes. So you might see those start to kind of pop up. From here to next class, you really don't have anything to do other than I would start looking at those practice problems for that exam next week. Start trying to review those early instead of cramming next week. Other than that, you'll have a quiz posted after class on Thursday for Module 4. And if you have any questions for me, or if you want to meet this week, I'm only going to be doing virtual office hours. So send me I'll have them open. But if there's a time that works for you tomorrow, I'll be in front of my computer most of the day. Send me an email. I can meet with you virtually. Friday, I'll also be pretty open if you want to meet virtually as well. And I should be back in my office next week, as usual, on Monday and Wednesday. So if we're starting to have questions over that exam, I can kind of give you some in-person help next week during those usual office hours. Okay? Questions for me before you guys get out of here? All right. I will see you on Thursday.